Find the derivative of a function involving tangent, cotangent, secant, or cosecant. Alright, so in this video we're going to talk about the derivatives of the final four trig functions of tangent, cotangent, secant, and cosecant. So let's dive right in. Now the derivatives of sine and cosine were fairly simple. They're just derivatives of each other, where the derivative of cosine happened to be negative sine. These four, however, not quite as friendly. They're not really that difficult, but they're just going to be a little bit unusual. So if we want to take the derivative of tangent in x, as it turns out, the derivative of tangent in x can be calculated by using secant squared of x. And then if we want to take the derivative of cotangent, cotangent is going to be, let's try that again. The derivative of cotangent is going to be negative cosecant squared. So if we take the derivative of either tangent or cotangent, we're going to end up with a trig function squared. Then moving along, if we want to find the derivative of secant, turns out the derivative of secant is secant times tangent. And then the derivative of cosecant ends up being negative cosecant times cotangent. Now there do happen to be a couple of patterns here. If we take the derivative of any trig function that starts with a c, such as cosine, cotangent, or cosecant, those derivatives are all going to be negative, whereas sine, tangent, and secant, those are all going to be positive. So hopefully that's one kind of shortcut that'll help remember which one's positive and which one's negative. Again, not super helpful, but it's a little bit. So let's dive in and take a look at our first example. So first up, we want to find the derivative of 2 tangent of x minus 3 cotangent of x. And again, when we take the derivatives, we know that we can kind of just ignore the coefficient and take the derivative of the function. So, taking the derivative, we're going to have dy over dx is equal to 2, and as we said before, the derivative of tangent is secant squared of x minus, I'm going to do that in blue, minus 3, and the derivative of cotangent we said was negative cosecant squared of x. And then from here we can just simplify a little bit. We know that a negative times a negative will be a positive, so that's going to give us a derivative of 2 secant squared of x plus 3 cosecant squared of x. Alright, next up, we want to find the derivative of y equals 2 cosecant of x plus cotangent of x over 2. Now this one is sometimes a trap problem for students because students will see, oh, cotangent of x over 2, that's a fraction. That means that we're going to have to use the quotient rule. And yes, technically you could use the quotient rule here, but it's big time overkill. Because the only time that we have to use the quotient rule is when we have a variable in the denominator. And there is no variable in the denominator here, so we're not going to use the quotient rule. Instead, we're just going to rewrite it so that it no longer is in fractional form. So we can rewrite this function to be 2 cosecant of x plus 1/2 times cotangent of x. So again, we pulled the 2 out. That became a 1/2, and 1/2 is just the coefficient of cotangent squared. Now we can go ahead and take the derivative. So let's see, y prime is equal to 2. And the derivative of cosecant is going to be negative cosecant of x cotangent of x. Plus 1/2, and then the derivative of cotangent is going to be negative cosecant squared of x. And then all that's left for us to do is simplify. So to simplify this out, we're going to get, let's see, negative 2 cosecant of x times cotangent of x minus 1/2 cosecant squared of x. And there we have our derivative. All right, next up, we're going to find the derivative of 5 sine of x minus 4 secant of x. So let's just dive right in. So choose the y prime notation again. Again, we can ignore the coefficient. The derivative of sine is going to be cosine of x minus 4, and we know the derivative of secant is going to be secant of x times tangent of x. And then we can simplify, and by simplify, the only thing we can really do here is just drop the parentheses, meaning our derivative is going to be 5 cosine of x minus 4 secant of x times tangent of x. And there we have our derivative. All right, next up, we're being asked to find the derivative of y equals secant cosecant of x. Now here, this is secant times cosecant of x, which means we're going to need to use the product rule. So I'm going to identify secant of x as my first function, and I'm going to identify cosecant of x as our second function. All right, so then diving on in here, we know that dy over dx is going to equal the derivative of our first function, and the derivative of secant of x is secant of x times tangent of x. And we're going to multiply that by our second function, and then plus the original first function, which is secant of x, times the derivative of cosecant, which is negative cosecant of x cotangent of x. And then we can go on and simplify. Really, the only simplifying we can do here is we can bring this negative to the front and drop the parentheses. So that means that dy over dx is going to be equal to secant of x times tangent of x times cosecant of x minus secant of x times cosecant of x times cotangent of x. Now this is a perfectly acceptable answer. However, if we wanted to show off our trig knowledge, we could actually take this a little bit further. So I know that secant is really 1 over cosine of x, tangent is really sine of x over cosine of x, and cosecant is really 1 over sine of x, minus 1 over cosine of x times 1 over sine of x times cotangent is cosine of x over sine of x. So we can see that we have a sine of x in the numerator and a sine of x in the denominator, so those will cancel out. In the next term, we have a cosine in the denominator, cosine in the denominator, cosine in the numerator, so those will cancel out. And then when we simplify this down, we'll get 1 over cosine times cosine is cosine squared, minus 1 over sine times sine is sine squared, which can be converted into being secant squared of x minus cosecant squared of x. But again, that is just me showing off my trig identity knowledge. All right, then the final question is just applying these trig functions to the quotient rule. So we're going to find the derivative of y equals 4x squared minus 3 all over tangent of x. And we know we're going to have to use the quotient rule here because we do have a variable in the denominator. All right, so I'm going to identify 4x squared minus 3 as my top function because, well, you know, it's on top. And then tangent of x is going to be the bottom function because you guessed it, it's on the bottom. So let's see, y prime is going to be the derivative of the top, which is going to be 8x, times the bottom, which is tangent of x, minus the top, which is 4x squared minus 3, times the derivative of the bottom. the derivative of tangent is secant squared of x. And then it's all going to be over the bottom squared, or tangent of x quantity squared. All right, there's not a whole lot we can do to simplify here, but we'll see what we can do. So 8x times tangent of x is going to be 8x tangent of x minus, I'm going to leave this as 4x squared minus 3 times secant squared of x, because we could distribute the secant in, but that really doesn't make it look any nicer or neater. So we're going to leave it in factored form. And then the quantity tangent of x squared can just be rewritten as tangent squared of x. And there you have it, our derivative. All right, folks, that is finding the derivative of a function involving tangent, cotangent, secant, or cosecant.